Hi guys! So last week we started talking about exponential functions and linear functions. This week we'll continue with exponential functions, and in this lesson we'll focus specifically on growth and decay. So whenever you have a situation that increases and we're adding or subtracting the same number each time to get from one term to the next, we've always called that a constant increase or a constant decrease. And we've referred to that as a linear function, which you were able to see in some of the notes from last week. So what we're doing now is we're talking about things that are increasing or decreasing by a percent. And those things can be expressed as an exponential function. So when we talk about this y equals b to the x power, where b is greater than 0 or b is not equal to 1, there are sort of two situations that can happen there. We can have a y equals b to the x where this b value is in between 0 and 1. And then we can have y equals b to the x where this b value is larger than 1. It can't be equal to 1 because 1 raised to the sort of anything power will just give me 1, and that would give me a horizontal line and not an exponential function. And it can't be less than 1 because if I think about what y equals -2 to the x power would look like, anytime x is even, it would produce a positive value, and anytime x is odd, it would produce a negative value. So I'd really end up with a graph that's looking something like this, which is also not representative of an exponential sort of model. So we put these restrictions on b, and then we can move forward and we can shift it around. So we can add to this model here and say that an exponential function is y equals a times b to the x, where a is my start value and b is my rate, or my percent increase or decrease. So I think once we do a few examples, it will make a little bit more sense, but let's take a look here. So it says the first year of a charity walk event had an attendance of 500. The attendance y increases by 5% each year, write an exponential growth function to represent this situation. So I'm going to take my y equals a times b to the x, and since we're talking about a percent increase or decrease, my b is going to turn into 1 plus my percent, since I'm talking about an increase here. So y equals a, which is my initial amount, is 500. 1 plus my percent as a decimal, which is 0.05 raised to the x power. So this situation would be represented by y equals 500 1.05 raised to the x power. And what's really happening here is I'm taking 1, which means I'm sort of taking 100% of what I'm starting with, and every year I'm adding 5% to that. But I know that 5% of 500 will be different than 5% of, let's say, 520. So how many people will attend in the 10th year? Round your answer to the nearest percent. So x is representative of my years. Y equals 500 times 1.05 to the 10th power. So what I can do is I can grab my calculator and I can do 1.05 raised to the 10th power and multiply that times 500. And that should give me, in the 10th year, how many people will attend? About 814 people. So here's an example. The population of a small town was 3,600 in 2005. It increases by 4% annually. Write an exponential growth function to represent this situation. So y equals my starting value, 3,600. 1, I'm talking about an increase, so plus 0.04 raised to the x power. So my equation simplified, 3,600, 1.04, not raised to the 0 power, raised to the x power. So what will the population be in 2025? Round your answer to the nearest person. Well, if my starting value, so we can say the year and the value in the equation. If year 2005 is year 0, then year 2025 is going to put me at year 20. So y equals 3,600, 1.04 to the 20th power. So now I can say, let's see here, 1.04 to the 20th power and times 3,600. Round our answer to the nearest person. This will give me 7,888 people. Great. Let's see, your starting salary at a new company is $34,000. It increases by 2.5% each year. Write an exponential growth function. So y equals my starting value and 1 plus 0.025 raised to the x power. What will your salary be in 5 years? We'll plug in 5 into my x value there. Let's sort of get to chatting about some of these decreasing pieces. The yearly profits of a company is $25,000. The profits have been decreasing by 6% per year. So we'll do the same thing here. Y equals 25,000, except since we're talking about something that's decreasing, 1 minus 0.06 raised to the x power. So y equals 25,000.94 to the x power. And I can see here, when I'm talking about something that's decreasing, my b value is going to be in between 0 and 1. So that is what will give me a decreasing exponential function. And then we can do the same thing. We can plug in 8 for x, round our answer to the nearest dollar. Let's just practice one more time creating some of these exponential decay functions. Your car costs $42,500 when you purchased it in 2015. The value of the car decreases by 15% annually. So y equals 42,500, 1 minus 0.15 raised to the x power. So y equals 42,500.85 raised to the x power. How much will your car be worth in 2022? Round your answer to the nearest dollar. So I can go ahead and plug in 7 for that x value and evaluate. So just looking here, these next few questions, 1 through 5, we can just talk about them together. So this right here, I have a starting value. I'm raising it to an exponent, and I have 1 plus 0.3 or 3/10. So since this is a plus sign right here, this represents growth. My initial value is 1,200, and the rate of decay or growth, in this case it's growth, is 30%. This guy right here is a minus, so we're talking about decay. My initial value is 55, and the rate is 2%. So here, I can see that this is made up of 1 plus 0.25, so this is representing growth. I can also tell that it's representing growth because my b value here is larger than 1, whereas in this case, my b value is in between 0 and 1. So this number 3 here will represent growth. My initial value is 100, and the rate is 25%. This is decay. My initial value, we just switched over to the highlighter there. My initial value is 5,575, and the rate of decay, we just have to be careful here. It's not 65%. So I want to think, what is the other piece that would sort of 1 minus what is going to give me 0.65. So 1 minus something is going to give me 0.65, and that's going to be 0.35, which is 35%. And then lastly, this represents growth. My initial value is 2,000, and my growth rate is 5%. So just by looking at these equations, we can really get a lot of information from them immediately. So these are sort of some great examples of problems that represent exponential growth and exponential decay.